We'll see about common base configuration. Before that, the types of configurations are common base, common emitter and common collector. In common base transistor, this one, base is grounded, input is in emitter, output is in collector. In common emitter configuration, emitter is grounded, input is in base, output is in collector. In common collector, collector is grounded or common terminal, base is the input and emitter is the output terminal. In all the cases, emitter based junction is forward biased and collector based junction is reverse biased. And now coming to common base configuration. So base is grounded, input and emitter. This ammeter measures the input emitter current IE. This voltmeter measures the emitter base voltage VEB, and the RPS voltage here is, since it's an emitter side, VEE. And then base, this one, the output side ammeter measures the collector is the outputs, right? So collector current IC. This voltmeter measures the base collector voltage VCB, and this RPS is VCC. Input characteristics is drawn for input voltage VEB and input current IE, keeping the output voltage VBC constant. So now this is the plot. As so for initial VCB equal to 0 volt, what happens here is it acts like a normal PN junction diode in forward bias only. This collector based junction, this voltage is 0, so it's a PN diode in forward bias. We get the same characteristic curve. And then when we increase this collector base voltage, what happens is, this is a reverse bias PN diode between collector and base. So the depletion width here between the base and collector increases, causing the reduction in base width. So this base width reduction is called as early effect or base width modulation. As we increase the collector base voltage higher, the base width reduces and finally becomes 0 itself, and it's called as punch through. So because of that, for a higher VCB, the curve shifts towards the left side in the input characteristics, because it achieves for VEB, we can achieve IE value earlier when VCB is a higher value. And then coming to output characteristics, it stands for output voltage and output current, keeping the input current IE constant. So for different IE, the values are plotted here, and we can see the curve is a straight line, which means IC is constant, it's independent of the output voltage VCB. And then the transistor parameters are, we have 4 parameters, H parameters. They are called hybrid parameters because they are of different unit. Input impedance HIB, which is input voltage by input current, del VEB by del IE, keeping the output voltage VCB constant. It's the slope of the input characteristic curve. Its unit is ohm. Output admittance HOB, change in output admittance. So output current by output voltage, keeping input current constant, unit is mho. Slope of the output characteristic curve. Forward current gain HFB, del IC, change in forward current gain. So it's in output current by input current, del IC by del IE, keeping VBC constant and no unit since both are current. Reverse voltage gain, so input voltage by output voltage VEB by VBC, keeping IE constant, and it is the slope of VEB versus VCB curve. Thank you.